Hey guys, so welcome to the very first lecture for measurement. Now this particular question, guys, I've seen this crop up a lot of times in tests around that grade 9, grade 10 mark, and my students have really struggled with it. So I just wanted to capture it in this particular lecture. So I hope that it provides you the insights that you need in order to be able to answer a question like this and similar questions to it. Okay, so the question says, a chessboard is made up of 8 rows and 8 columns of squares. Each little square is 42 centimeters squared. What is the distance from the upper right to the lower left corner of the chessboard? Okay, so what we need to do, just to make it a little bit easier to understand this, let's just quickly draw this out as quickly as we can, or as as helpful as we can. So we have 8 squares. Now obviously this is not the square scale, guys, so please don't judge my drawing here. So we have 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And then we're obviously going to have, the 8 squares going this way. 7, 8, and then we have the 8 squares this way. Obviously, I'm not going to draw them all out, but I just wanted to give you guys 1, 2, 3, 4, 5, 6. Oh, let's make that a little bit bigger. Okay, so that's my really poor rendition or poor representation of this particular chessboard. Okay, so what this is basically asking us is to figure out this particular length there. So from the top right hand corner to the bottom left hand corner of the chessboard. Now, as the question says that this particular chessboard, each little square has an area of 42 centimeters squared, which is basically length times length. So length times length is equal to 42. So L squared is equal to 42. So taking squared to the other side, we have square root. So L is equal to square root of 42, which gives me a value of 6.48 centimeters. So the length of each of the small little squares is 6.48 centimeters. So this little length there is 6.48. This little length there is 6.48, etc. So you get the point. Okay, now you might have already seen that this actually makes up a big triangle because this is a square block. So this particular, let me use a different color here. So this particular shape is in fact a triangle. And this particular side here would simply be 6.48 multiplied by 8 because that's how many small squares make up that particular length there. So 6.48 multiplied by 8, which gives us 8 times 8, which is 64. 8 times 4, which is 32, plus 6, which is 38. 8 times 6, 48, plus 3, 51. Then that has 2 decimal places, that has 0, so in total there are 2. So this gives me 51.84 centimeters. Similarly, because this is obviously a square, so that will also be the same. So that is also 51.84 centimeters. So let me just draw out this particular triangle out again. So we have this triangle. So we have 51.84, 51.84, and this is the distance that we need to find. So let's call it C. So using a different color, let me attribute different letters to them, and this can be C. As you might have already guessed, we need to use the Pythagoras Theorem to figure out the C. So this is something that you'll often notice, guys, in these, at these types of levels, where you have to bring in, knowledge from different topics to answer a specific question, which might not be too relevant to the topic at hand. However, you will need to learn, or you will need to know, you need to have a fairly vast amount of knowledge to answer specific questions like these. So we have a squared plus b squared equals c squared. So 51.84 squared plus 51.84 squared is equal to c squared. So c is equal to the square root of this, which gives me a value of 73.31 centimeters. So what is the distance from the upper right to the lower left corner of the chessboard? It is 73.31 centimeters. Fantastic. Let's move to the next question. So this question says, A satellite is revolving around the planet Mars at a distance of 3,450 kilometers from Mars's surface. Now, if Mars's radius is 2,345 kilometers, how much distance will the satellite cover in one rotation of Mars? So again, let's just quickly draw this out. So let's call this Mars here. Okay. Now, Mars has a radius, apparently, of 2,354 kilometers. Now, apparently the satellite is, again, from another distance. Let me use a different color, actually, so it stands out. At a further distance of 3,450 kilometers, there's the satellite there. It is traversing around Mars. So that's the distance that it's covering. So the satellite actually has a radius, or the space that the satellite is covering has a radius of 2354 plus 3450. See how it makes it a lot easier to understand this particular type of question after you've drawn it? So 4 plus 0 is 4, 5 plus 5 is 10, 4 plus 1 plus 3 is 8, and 2 plus 3 is 5. So the total radius for the the part that the satellite is covering is 5,804 kilometers. Now the question asks, how much distance will the satellite cover in one rotation of Mars? So basically they're asking for this particular distance there, that right there. How much is that? And that, you might have already guessed, is simply the circumference. So the circumference of a circle, as we know, can be given by 2 times pi times r. So we'll say pi in this case is simply 3.14. And radius, as we know, is 5,804 kilometers. So this whole sum gives us a value of 36,449.12 kilometers. So the satellite will cover a distance of 36,449.12 kilometers in one rotation of Mars. Cool. Let's move to the next question. Okay, so this question says, a sheet of paper measures 25 centimeters by 17 centimeters. What is the area of the sheet? Okay, fairly straightforward. So we have, let's draw this out. Even if it's straightforward, guys, please do draw it out, okay? So we have 25 centimeters, and we have, how much? 17 centimeters. Okay, so obviously these two are the same sides, these two can be the same sides. What is the area of the sheet of paper? That's pretty straightforward. So area is always the length times the width, which is 25 times 17 in this case, giving us a value of 425 centimeters squared. Part B, what is the radius of the largest circle that can be drawn on this sheet? That's an interesting question. So let me use a different color for this. So the radius of the largest circle, so the circle has to have, imagine the middle of the circle being right in the middle of the paper. So that would be, the radius of the circle right there. Now you'll notice that I'm not actually reaching the edge of the particular paper in terms of its length. Why? Because we have to have a radius of only 17 divided by 2, which in this case is 8.5 centimeters. Which is the largest radius that the circle can have, because anything larger, and it'll actually go outside of the circle, or outside of the sheet of paper. So this is the particular circle. Hey, that actually turned out quite nicely. So this particular radius is 8.5 centimeters, because again, if we were to say, if we were to use this particular side, which would have a radius of 12.5 centimeters, we would know that, this would cross this particular side here. So it'll cross this way and it'll cross this way. So it'll actually be outside of the sheet of paper, which is not what we're asking for. So what is the radius of the largest circle that can be drawn on this sheet? It is 8.5 centimeters. Now part C says, what is the area of the circle? Straightforward. As we know, the area of a circle is simply pi times r squared. Pi is 3.14, and radius we just found, which is 8.5 squared. Putting this straight into the calculator, I get a value of 226.87 centimeters squared. All right, now if the circle is colored red, so let's color it red. Let's do so it stands out. All right, so that's been colored as red as much as we can. What percentage of the paper is red? Okay, that's interesting. So we have an area for the circle, which is 226.87 centimeters squared. We have a total area of 425, which is the area of the sheet of paper. So it is simply 226.87 out of a total of 425. Then you multiply this by 100, and we get a value of 53.4%. So if the circle is colored red, what percentage of the paper is red? 53.4% of the paper is red. Okay, so let's move on to the next question. Alrighty, so this question says, a beam of light is being projected onto a stage as shown in the diagram. How much area is being illuminated? Okay, so we have the light, which is sitting here. Let me use a different color so it stands out. So that's the light right there. And the yellow portion is the area that's being illuminated. Now, you might have already seen, guys, or you might have already guessed that this is simply a sector. So, which is just a proportion of a circle. And the sector in this case is 60 degrees. Now, we know that the area of a circle is given by pi times r squared. Area of sector, on the other hand, is given by the number of degrees that we are working with, so let's call that x, over the 360 multiplied by the area of the circle, which is pi times r squared. So x in this case, as we know, is, that's right, 60 degrees. So we have 60 over 360 multiplied by pi, or let's call it 3.14. And radius, as we can see from the diagram, is 5 meters. Okay, so that's 5 squared. The zeros get cancelled out here. 6 goes into 6 once, 6 goes into 36 6 times. Now we have 1 over 6 times 3.14 times 25. Now putting these all into the calculator, we get a value of 13.08 meters squared. So therefore, the answer would be, how much area is being illuminated? Therefore, 13.08 meters squared of area is being illuminated. So guys, that brings us to the end of the first lecture for measurement. Again, I've just sort of split this up into 2 lectures just so we don't cram too much into the one lecture. I hope it was helpful. Make sure you have a go at the worksheets. Make sure you go through the lecture a couple of times if you need to really help you cement some of those learnings there. So guys, thanks again, and I will see you in the next lecture.